Hello, good afternoon everybody to this tutorial. My name is Hajo Reyers. I have the honor to chair this tutorial session. The tutorial itself will be given by Professor Stephanie Rinde-Lema. She's a full professor at the Faculty of Computer Science of the University of Vienna, where she heads the research group on workflow systems and technology. She's a very well-known member of our community, very much respected. She did groundbreaking work on flexible process technology, which is also one of the ingredients of the tutorial in this afternoon. But you will mix that with Internet of Things and industrial manufacturing processes, and I'm sure a lot of other interesting concepts. I've already heard that many people were looking forward to this tutorial, and I'm very glad it's part of the program. I will very quickly hand over to her, but first remind you of the 3 different ways of how you can interact during the tutorial. There is the button on the Zoom application where you can raise your hand. I also know that Stephanie will once in a while also actively ask for your participation. So this is one way of getting involved. You may use the question and answer functionality to formulate questions, especially if you do not want to engage directly with her, because it's a scary question, for example. And you can use the chat function. What I will do is, together with Sergio, we will monitor the questions while Stephanie is delivering the tutorial, which we hope you will thoroughly enjoy. Having said that, I will hand over to Stephanie, please.
Thank you very much for your kind words, Hajo. I'm really honored to deliver a tutorial today here at the BPM conference. And yeah, as the title already says, we talk about digitalization. So yes, perfect setting, we are online. Not so much for the traveling aspect, but okay, if we want to talk about this, then it's, yeah, this online setting is very much fitting. But we will not go like into how to proceed with online conferences, but we will look into a domain that is also very challenging from a digitalization point of view. And this is the manufacturing domain. And fortunately, I'm not alone here. So here I'm in our lab, but I have 2 members of my group, Jürgen Mangler and Amol Hirat Singh Mangat, who will, who are very much looking forward to deliver the online exercises and going to take you on the shop floor here in our lab. So what is to expect? So in the end, after the 75 minutes of tutorial roughly, we want to be able to master the following scenario. So as I said before, we are here in the lab, and what we recently got for the lab was a so-called cobot. That's a collaborative robot, which means it's a robot that can interact with human workers. And what we want to do is we want to specify a process, but not only model it, but also execute it and drive the cobot. And what the cobot is supposed to do, it should recognize an object on a table. You can see this here on this orange table, some objects, automatically then pick up this workpiece and then put it on a tray on a specific position. So yeah, this is of course some experience, and I hope it will work through this online setting. And but I think it's maybe nicely illustrating how BPM software in general and the physical world with the cobot can be connected and yeah, nicely interact with each other. So why I'm so interested in manufacturing processes? So I think manufacturing processes are very challenging and interesting to look at because they combine so many aspects. So we have the control flow of the processes, which can become fairly complex. We have this interaction with the physical world. Yeah, so the processes can manage and interact with machines, robots, and sensors. But we also have human aspects because still there's human work involved in these processes and the information systems that are in place at the companies and factory site. So basically we have, this many aspects, and processes are really the key driver here to integrate all of these aspects in a process-oriented way, which I try to motivate why this is a good way to integrate these aspects. So let me maybe start with a real world case to illustrate what we mean by manufacturing processes. And this first scenario is a robot that interacts with a machine. And these are real world robot and machines. They are situated at the so-called pilot factory. That's a factory that is located here in Vienna. And we can also use and play around with this factory as scientific partner of the Austrian Center for Digital Production. But it's real world because you can also produce real world parts here. And what you can see here on the left-hand side is the process, which is then driving the robot interacting with the machine. So let me start the video. So as I said before, you can see on the left-hand side the process. That's, let's say, the super process that drives the entire interaction. And now you can already see by the animation, so it's not only animation, it's already execution, yeah, that different tasks are executed and sub-processes of the super process are spawned. And on the right bottom, you can see the machine with the workpiece. What we actually want to produce is a chess tower. Yeah, so you can see now the raw material, and the process is really driving now the machine. So it starts to turn, and we can see that already the processing of the parts starts. So in the first step, there's more raw processing where you cut the raw shape of the tower, which we can see here. And in the process, you can see, okay, the super process is in a state wait for machining to end. And the sub process is active. So the turning of the machine is executed here. So you can see how the shape of this tower develops. And we took here also some little bit pauses and slower movements to see everything and to also see what is happening in the process. Okay. So now the more fine-grained processing of the tower starts. And I'm really fascinated by this because this is how really something is happening here. And what we have to do is that from the process, of course, we have to connect to the machine. And this also, for example, is a lot of work in implementing, for example, all these protocols, how you can really access the machines. For example, there are standard protocols like OPC-UA or so, but of course you have to manage to connect really these physical devices to the process. Here it's a different view now, it's from the top, and that we can see better what happens. And now the tower is already cut, and roughly at this stage, it's finished. So you can see like these machining sub-processes stopped now and disappeared because they were completed. And now there are two measurement steps in this process. Yeah, so for quality control, we not only have to produce the part, but also we have to see whether or not the quality is sufficient. And there's two ways here to measure the tower that we have produced. One is with scanning the part. This is the first one here, measure with key-ins. And for measuring the part, the robot has to take out the part from the machine. So this is now one of the sub-processes here, the lower one where we can see take out, and now the gripping of the part. And it's a little bit slower than in reality that we can see everything happening again. And now the extraction starts. It's hopefully done. Yes, now we see the extraction. And what we can say here, what is a very important point, is that during all these steps, yeah, let's say the machining before, taking out the part, and now the measuring, the process also in parallel collects all the necessary data connected with these tasks. Yeah. So for the machining, for example, there could be different data interesting. So the power consumption of the machine, for example. And then, of course, with the measuring tasks, there's also a lot of interesting data measured. So now we can see that the robot puts this into this scanning device. And by this integration by the process, now it becomes possible that all of this data is connected together in a process-oriented way. And that's really new, because so far, if you go, let's say real-world factories, often the data is collected more in an isolated manner, let's say per machine. So they have to like data silos. Yeah, maybe I can measure all the data connected with the production machine. I can measure all the data maybe with the follow-up workstation, but this connection is missing. And I think here entirely new door opens for data collection and analysis. Yeah, we can see here now the scanning of the part and so on. I mean, maybe I will go to the end of the video because it takes now some time. So then the second step, the second measuring would take place here. And as I said before, we then have at the process level, the data of both measurements at hand and can, for example, compare the both measurements within the process. And then, for example, if we see that there is maybe some problem with the part, we can look back into the data that we have collected with the machining and then see maybe from sensor data that was collected that there were already some drifts or something happening in the sensor data. And this is so interesting. So this is, I think, one of the benefits of such a solution is not only to execute such processes, but this data collection part. And I think this is also a little bit in line with what we heard this morning in the keynote. So we have now the process data, the event-based data, where we can do process mining with, but we have also all this additional data like sensor data and so on, where we then can combine this with, for example, machine learning methods. Okay. But we can not only think about such processes where everything is completely automated, like in the first example. Yeah, here was a robot and a machine, but we can also think of the human in the loop. Yeah, this is also a very important thing to do. And this is a second example from our work where we have implemented a process-oriented solution within a company. The company is the EFA GmbH here in Vienna, and they produce locks and safety solutions. And here we have the production of so-called e-cylinder. And you can see the process on the left-hand side. And you can see the first workstation on the right-hand side. And what can be done here? So in the first step, you can scan here which part has to be processed now. And then by scanning this, the process already automatically knows what part is produced. I have to say that the parts here lead to around 60 variants of the process. So here you can also see an example of production with a high number of variants to be produced. You could also load this information about the part from the ERP system, for example, but this was a specific requirement by the company partner to have this scanning of the product here. And then at the next workstations, and here we can see this inclusion of the human, the process can be also used to give instructions to the workers at the specific task they are doing. Yeah, you can see here on the user interface, and you please keep in mind that we have all these variants, so not all the instructions are the same for this task, but depend on the variant that is produced currently. The workers can be guided by these instructions. And this is a huge benefit because so far they have worked with paper-based documentation. So I don't know how many pages, but it was several hundred of pages of documentation that had to be consulted for the steps. And some solution like this, then of course is, let's say much more informative and quicker to consult. This is the next workstation here where again instructions are presented. And as I said before, first of all, this yields to a reduction, of course, of complexity and effort. And also, as we learned in the current situation of crisis, also there's a demand, for example, for companies that, let's say, staff or teams changes more often. And here then, of course, let's say new workers that have to be instructed can be more easily integrated into the process here as well. Right, so these were two examples. One, let's say, more on the automated side of the spectrum, and one including human workers. So are there any questions regarding these two examples at the moment?
I think you're fine.
Okay, right. So a first key message maybe for us looking at this domain now for, let's say almost 10 years is that process technology can really help to drive digitalization for manufacturing processes. I have to say that, of course, production and manufacturing is already a highly digitalized environment. Yeah, so there's a lot going on, what the robots can do and so on and so forth. What we think where processes come into the game is really in this integration part and also in this data collection and providing new ways of analysis are part of the production side. So what we have already seen, we have seen two real-world examples for such manufacturing processes, automated one and one including human workers. I, in the next slides, want to introduce a little bit the background technology in state of the art, because it's not only an application-oriented question or research, but it also connects to many, many interesting fundamental research questions. And then in the end, we want to provide some insights by a hands-on experience where we developed the scenario mentioned in the beginning. So I try to give an overview about the research areas that are necessary to be understood to develop such manufacturing solutions. And I don't claim that this is a comprehensive or complete picture, but these are some of the areas that are touched and where state-of-the-art research is also currently going on. So let's say the outer side, I definitely think that the problem sits at the interface of BPM and IoT, obviously. Then with this data collection and analysis part, we have, of course, questions how to analyze and visualize the data. Then, as also mentioned by Hajo in the beginning, I'm always interested in change and adaptation of processes. And this is also really necessary in this domain because exceptions can happen at any time. And where currently in some situations there is one expert listening to the machine and hears maybe that there might be a problem in some certain time coming up, we think it would be maybe more structured and more sustainable to analyze the process and maybe predict this problem from the data that we have, and then also be able to suggest and apply adaptations and repair actions. And of course there's huge aspect of execution automation here. And as a disclaimer, I will not talk about robotic process automation. I think there are a lot of interesting talks at the conference, but we here talk now about processes that involve robots and cobots in their work. And as often the case, I think the really also interesting questions arise at the interfaces between all these topics. And I will try to comment a little bit on this in the following slides. So let me start maybe with BPM and IoT. IoT stands for Internet of Things. And there is a recent article on Internet of Things meets business process management. And I think it nicely summarizes a number of interesting challenges in this area. And these challenges are put along the process life cycle. So if you see the rough phases, modeling, then enactment and execution, and then prediction and adaptation, we can put this into relation with the challenges of manufacturing processes. So first challenge is, of course, how to include sensors and machines in such processes. And here a lot of nice questions arise. So at a model level, we have to, for example, deal with the question how we can annotate models and tasks with sensor information, for example, that the user knows, okay, here's a task where sensor data is, for example, collected. Then, of course, we have to think about how we really can log sensor data then afterwards. So also maybe we have to already at the design time, we have to include the sensor sources at the task to see where afterwards the sensor information comes from. And then this, of course, plays then into the execution part where then the sensor data is actually collected. And then in the prediction adaptation phase, how we can then analyze both the process and the sensor data in combination. Then humans, also very important factor here. With the modeling part, we could, for example, think about, do we have manual automatic tasks? Then what is also from our experience in practice a huge topic is worker assistance. Yeah, so in the one example from EFA, we have seen that like this guidance or instructions is really helpful and necessary in practice. And then if we think about, let's say, adaptations of processes, we not only have to make sure that adaptations are correctly applied, but also we have to support users in defining the adaptations. And this is often, let's say, also a huge challenge because, maybe the expert can hear that the machine will run into some not so great state, but what to do to the process then afterwards is maybe another question. So here we talk about support of domain experts, which are not necessarily equally to the process experts. Yeah? So it would be also nice to see maybe from the data, from the prediction, what kind of process evolution or adaptation will be necessary afterwards.
It is nice, Steffi, that this is also a human in the loop aspect, of course.
Yes, yes. And I had this before the keynote already on slides. It was no ad hoc adaptation afterwards. So I think it's really very, very important aspect. And it's important that we talk about it because one of the fears sometimes connected with introducing processes is that, so all the work will be automized and there will be no work for human workers left and so on. And so I think it's really important to say, well, maybe the work will change a bit, but the main goal is the support here at this stage. For acceptance, I think this is very, very important and essential. Because if you have all these hurdles then in the organization where people don't want process management, then it's, a bad start right away. Okay. So what we have seen is, we have the manufacturing process design. And here I want to distinguish between, let's say, two phases in the design. One thing is definitely the modeling. And here we want to offer users also, along their mental map, they have standard modeling notations like BPMN, for example. So here you can see like the interface again of the solution that we have developed. So you can model along BPMN, but you can also import BPMN models that you have modeled already. You have also a repository of models, maybe something you have specified before and you just want to adapt and use later on. And then as said before, all these other questions come into place. So for example, where are tasks where I can use sensor data and so on. And the second phase, maybe I put this afterwards. The second phase is then the execution design, because we have to really be aware that the models are then becoming programs that are executed. So there's definitely not no code, but let's say low code plus this model-based approach that we use here. And but there's no free lunch, let's say. So if we have modeled the process, we also have to, of course, define, for example, how to connect the machines, how to really connect the sensors. Here we have to deal with all these protocols that I've mentioned before. But also we have to see what happens if, for example, there's no response from the machine or there's only a partial response, how to handle problems, and so on and so forth. So this is, I think, a very structured and usable approach towards then afterwards having a really executable program. But yeah, this information has to be provided at some place to be able to execute something. What can be offered here is a step-by-step testing. So we can use, for example, yeah, something like testing or dummy services. So you can see how the process executes before you really connect the machines and the sensors and really something is done. So this is, let's say, beyond model checking and simulation. Also this test mode can be interesting here before you really go to the real world and I don't know, use the $1 million material or something. And now let me come back maybe to this human factor. So I mentioned some of the currently going on research. So I think from the practical side, we have this demand from companies to have worker assistance based on the process. This can also lead to, yeah, something like using augmented reality, where people not only see the user interfaces and do something, but maybe really, yeah, are trained using augmented reality on some tasks. There is work on assigning tasks based on abilities. I think it's also quite interesting in this context. So there is work on manufacturing, but also more general work on this. Then what's also a huge issue in manufacturing is safety, because a robot, if it's programmed to do something, it will do it, regardless if there's an arm or a leg in between. So safety is really a huge issue. And for users to really work with the process, we could also use it to visualize safety risks, for example. And also privacy is a concern, and there's also ongoing work here. So you see, yeah, people are thinking about design and then also this human-centered design of manufacturing processes. And I think there's also still, yeah, many things to do in this direction. Right. Yeah, the second part is the part which I also regard as highly interesting. And the keynote this morning was also, okay, process data used for process mining and sensor data then maybe more with the machine learning approaches. And I think here is one of these exciting areas where you can really have both of this data to be analyzed. Hayo, you wanted to ask something? No? Okay, sorry.
I'm sorry, I was checking whether there were questions and then I pushed something.
Okay, sorry, yeah, it was. Right, and let me maybe go a little bit deeper into this. So for the data analysis and visualization part, first of all, I think this was also a question very nicely referred to in this morning's keynote. What does process mining do? And in a very recent book on process mining in practice, there I found two statements which I can also really yeah, relate to. So we talk about digital transformation, and here it's stated that transparency is a prerequisite for digital transformation, and that process mining is the enabler of having full transparencies on the event logs. And I think this is quite true. So process mining in general is also very interesting for the manufacturing domain. I don't want to go into process mining here. There's textbooks, as said by Avi this morning as well. But what I want to comment on is on the combination of the process mining with the sensor data. So maybe let me first go into the data part. So in a analysis project first, and this is often the most expensive part of such a project, you have to find, collect, prepare the data. And it's a very good question how to bring together the process data with the sensor data. So first of all, for the process data, we have questions. Okay, we have event-based data, sure. But then a question is, what about the life cycle? So what life cycle states do you support in collecting the event data? When you look at logs, sometimes there's a completion event, but let's say for interacting with the machines, sometimes would be better to also have a corresponding start event, because as we also said before, sometimes the machine gets stuck somewhere within the execution, and then you won't have a completion event. And it would be good to have maybe the start event to relate to this event too. Even maybe more lifecycle events would be even better. So this is one claim that we would make, that you collect your process data with a sufficient distinction of lifecycle states. Yeah. Then sensor machining data is highly interesting. So, and this is often collected in form of time series data. So we have, let's say, temperature or pressure, or we can also have power consumption, which is then measured continuously over time. Yeah. And then the question is how to bring this together with the event data. So you can have this like separately and say, okay, maybe you form from the sensor data something, I don't know, using complex event processing and do something with that. We want to really do a combined analysis of both data, because we found that, for example, if you can observe drifts in the sensors and you can connect it to the process, these drifts in the sensor data might even indicate drifts in the process later on. So sometimes in the machine you can see, I don't know, if the temperature gets too hot for a certain time, then there might be really some impact on the product that you have produced. And I think this is not only valid for the manufacturing domain, but also for many other challenging domains like medicine. Yeah, you have also a lot of sensor data, blood pressure, heart rate, and so on. Or also logistics, yeah, also temperature plays an important role here, and so on and so forth. And have this connection and know or find reasons for a process behavior within the sensor data can be very promising, because then you can learn from it and even also do predictions based on the sensor data that you observe.
Can I ask you a question?
Sure.
So what I also have heard is that when in settings where you have multiple sources of data, that the sources of data are also sometimes need to be, that there is a sort of a selection problem, which is the best kind of stream to represent a particular event, or what is the most reliable one. Is this also something that you recognize?
Definitely. Thank you for the question. This is a highly relevant problem. So also in the paper we also then going to present on Thursday in this track, we comment on this, the selection, for example, of the right sensor or sensors to yield, let's say, the explanation for the concept drifts afterwards is a very relevant problem, because you might have a multitude of sensor data. So you have, for example, one case where we, I think, have 80 sensor streams at the same time. And this becomes already very complex, not only in doing the analysis, but also then afterwards in the interpretation, of course. So here, this is definitely very worth looking at it. And for us, also still an open question and worth doing some research on this, on how to find out what sensors are really relevant. Of course, you can try out all of these, but maybe there should be something smarter than that. Yeah, and then if the scenario becomes more complex, also performance might play an important role in the logging, because manufacturing has really high, let's say, real-time demands. And we have to be, it's a question if it's even possible to be as fast as the real-time expectations are. But of course, we have to really do all that we can to not let's say, slow down the process or the execution by, for example, having problems with the logging in the background. Yeah, so we have to really think also about performance issues in these settings. Yeah, and then as also said by Avi this morning, one of the important tasks is then to also present the data to the users, to the domain experts, to the analysts, and so on and so forth, like in an explorative way, for example. And for process discovery, the model is typically graphs. Yeah. The question is, what are the models for sensor machining data? So this time series visualization can be done, for example, as displayed below. Here you see also one of the cases we had. And here you measure the 3 dimensions, how the machine moves around the work item. Yeah, before you've also seen like there was this tower, and then it was turned out. And the machine then kind of, yeah, moves around the workpiece. And here this is measured in a 3-dimensional way. And you can put these 3 streams, let's say, together and produce the movement of the machine. And the domain expert, by looking at this, can directly say something about it, according to our experience, say this was good or not or so. I mean, I can't, I'm not really an expert on the engineering part, but this could be, for example, a model to visualize this sensor machining data. Still, I think it's also interesting to look a little bit more into models to visualize both the process data and the sensor data. This is also hand in hand with how to collect the data, but the visualization might be even more interesting. So if you have like multiple time series per task, or how can you do that in a very, let's say, in an informative way. And then commenting on the analysis. So what we actually want to do now is we want to use process mining, but we want to include data. And this is no new idea, so this has been followed for many years, the general question of how to include data in process mining. So, for example, there was this, all this work on decision discovery, where based on process data, you want to discover the rules behind decisions, alternative branchings in the process. Or if you look at conformance checking, also there's work on taking several perspectives, including the data perspective, into account. Mostly these approaches consider more like the process, the internal process data, if I might call it like this. External process data has started to be considered. For example, there's some work where external data is used for predicting failures in process executions. And we want to move, because the experts say that this would be really interesting, towards the direction of really explaining drifts, for example, in the process execution by drifts that we observe in the sensor streams. And of course, as I said, one of the problems is to select the right sensors that really explain the behavior, and there are many other questions here. And also for conformance checking, this could be interesting, because we could base our the costs of deviations, which conformance checking kind of takes into consideration, based on also the data that we observe. Yeah, and then finally, let me comment a little bit on runtime adaptation and repair. So there's a whole body of work on process change. There's also books on it. So this is a very relevant line of research for many years now. I think has also gained some momentum nowadays again, because I think all of our processes were very disruptively changed recently. The line of research has dealt with many aspects. I think one of the prominent ones was that you cannot conduct change however and whenever you want, but you have to deal with correctness issues to not run into problems afterwards. And there were also first works to deal with how you can find the right change for, let's say, an exceptional situation. And we also observe this in the manufacturing domain. So there can be always errors due to many sources, due to many reasons. So there can be errors, right away errors, something is going wrong. And there could be also for example, rare cases. This is not really, of course, no error, and yeah, but also might lead to something that you won't expect. And for different reasons, you would want to modify the process, and even during its runtime. I think this is so important to mention. Yeah, you can, of course, also go and model a new process and start it over again, but often this is not possible. So changing a process is changing a running program, and this has to be done carefully. So yeah, what would be good is to, for example, at least be able to start and stop instances whenever it has to take place, but also, for example, change the thread of control, skip some steps, or even insert some tasks. So all of these operations are really important, but have to be really handled with care for avoiding any side effects afterwards. Right, so this was my quick overview on related work and background technologies. It touches upon many, many points. Are there any questions at the moment?
Hi, Stephanie.
Hi.
May I interrupt you for a minute?
Sure.
There is a background noise. I'm not sure if you could do something about that.
Oh, really? But here, okay.
I don't know if it comes from your lab or perhaps it's the microphone. I mean, it's not that bad. Just simply if you could make some checks.
Okay, yeah.
With the connectors or.
Because here the background is really silent.
Okay, then don't worry. I mean, if you cannot fix it, it's just okay. We can hear you well. It's just a bit annoying.
Okay.
But it's
sorry,
okay.
sorry,
No
but here it's really totally quiet. It's
okay,
weird.
It must be the microphone. No problem, please.
Okay, the others said they don't hear any background noise, but
there is a sort of a zooming, as if there's actually as if you're in a factory.
In a factory, okay.
Yeah, exactly.
Background.
Okay.
Well, don't worry, Stephanie. If you cannot fix it, go ahead, please.
We can. No, it's not that bad.
It's not that bad. Okay.
It's a quiet machine.
Should I try to fix it?
I don't know. Okay, we try one thing, okay, but not too long.
Okay, okay. Thank you.
There is a. Now, by the way, maybe it's a good time to
yes.
give Felix the opportunity. Felix, one moment.
Now it's perfect. Can you?
Ah, yes, it's perfect.
Yes.
It's gone.
Can you speak now? Can you speak now, Stephanie, to make sure that we can hear you?
Hi. It's better?
Yes, I mean, there is no background noise. We can hear you very low.
Low? Okay, we can.
Faint. Yeah, we hear you very faint.
Better?
Better.
Yes, perfect.
We can
perfect.
even
Perfect.
pump it up, the volume.
No, perfect. This is
okay,
perfect.
good.
Perfect. Thank you so much.
Yes.
I'm going to.
I have very capable team members.
Very good. I'm going to give Felix
Sure.
The opportunity to ask you a question. Go ahead, Felix.
Yes, can you hear me?
Yes, I can hear you.
Very, very good. Thanks for the nice introduction to process support for manufacturing. I wonder, and maybe I missed this because it's quite warm here where I am, so I might have missed that, how data quality plays into this, because that was my experience doing some projects in the manufacturing domain that basically we always try to do some analysis of things, and it turned out, no, you cannot really use any of the stuff that they record.
Yes, very, very good point. I think I very implicitly touched upon this by saying that the data preparation part is the most expensive one of most of these projects, because as you say, you can start doing something and then in the end you can throw away everything because the data quality is so low. So I experienced this very much in the medical domain, for example, where we had even handwritten logs or Excel sheets which were called a database and so on and so forth, particularly if you have heterogeneous data sources and have to bring everything together. So For the manufacturing domain, what I presented now is that we already collect the data in the way we want to collect it, because we drive this with the process engine and we run all the processes ourselves and provide the opportunity to collect the data in a contextualized way in the quality that we want to achieve. But I totally agree, data quality is a huge problem. And yeah, as I said before, in the medical domain, we even had to go all the way to recollect the data. So it was not usable at this point.
Yeah, so there basically, whenever you have machines, kind of, they would directly feed into the system. So I see that's very nice, and you get all the nice data quality. I just wonder where the human, when the human interacts, if that.
Well, yeah. So maybe I can add. This is also how we sell this to the factories and the companies. That this provides you with the opportunity to collect the data the way you want. This is also something, maybe a selling point, because they understand and they want to analyze and predict and everything. But if you tell them like, you're doing this now, this is not working. And with the human, well, you mean that maybe you can ask you back. So what can the human potentially mess up with the data?
Oh yeah, I mean, for like a classical example would be that you have logs when certain work steps or something were conducted, and then you see that they basically log this after they have done this in the evening or something like this, or they are logged like start complete, and
yes,
that
that's
could
right.
still happen here.
Yeah. So this is something which we experienced a lot in the care domain, for example, because this is all paper-based, and because of all the time pressure, the nurses treat the patient the entire day, and then in the end of the shift, there is a certain tiny time frame where they can do all the documentation, and there's things forgotten and everything. So again, we try to also guide users by this process-oriented solution, even with these instructions that we provide, in order to minimize these effects. But yeah, as soon as you have partly paper-based, let's say, documentation of the things, that's a huge problem.
Yeah, thanks. I just wondered.
Sure, yeah.
Very good.
Thank you.
So I'd say in the interest of time,
okay.
Proceed.
Okay, great. Yeah, thank you very much for the very nice questions. Then this would be an architecture for such a system. And maybe what is interesting is, the design part. You not only have the process designs, but you have also the designs for the products. So you have all these technical drawings and everything, which you have to also consider. And at the runtime part, you have these connections to these physical devices via these protocols, OPCOA and MQTT and everything. So, and then of course this data part, which we will now also comment on in the demo. So maybe I just summarize at this moment the lessons learned and benefits before going into the hands-on session, that we don't miss this afterwards if we really get into it. So what I think is the great thing about manufacturing domain is that we have the integrated execution of everything: processes, machines, human tasks, information systems, and so on. And the huge benefit of implementing a process-oriented solution is that you can collect the manufacturing data already in a contextualized and process-oriented way. And this enables also this integrated collection of process and sensor data. And this enables in turn, of course, a more comprehensive analysis and understanding this transparency that we talked about in the beginning, that is such an important aspect of digitalization. And as a more future point, which I could not really comment on, but what is also, let's say, always a huge selling factors for project funding and everything, is that you want to go, let's say, outside your company. So with processes, you can be also able to form like process networks with multiple partners. And this is under this buzzword of virtual factories. So we had an entire EU project on this. But let's say for reality, we are not yet there, but I think we have to keep this in mind, because this is also a very interesting way to go. Yeah, there's some references and of course some thanks. So Jürgen will now also do the demo and show the hands-on experience, and Florian is working with EFA and provided these nice slides on the use case at the EFA company. Right, now let's go into the scenario and we will start with a demo.
So, hi guys, can you hear me? Yes.
Yes, very well.
Everybody is nodding. Okay, I switched to the other view that you can see here. For today's demo scenario, we will use the robot in our lab. And you may notice you now should see, like on the right hand side, you should see two different camera streams, which is the robot view is the upper camera stream. The camera stream has a delay of about 4 seconds because we have to take the picture and internally work on it. For example, take it for some to analyze by neural networks. So there is a little bit of a delay. So when I put my hand below the camera, you can see me move away from the from the stream in the zoom, and like about 4 seconds later, you should see my hand appear under the camera. So you can also see the total view of the lab on the lower end. So you can see myself and Stephanie, but a little bit later because of the camera delay. And here is the setting. This is a universal robot. 5, the 5 stands for actually he can handle up to 5 kilograms. He has a, if he's stretched out, he's about 1.5 meters wide. This is the control panel of the robot, where you can typically do all the programming. And the scenario, as you see it here, is basically a work organization scenario. So we have put several cylinders on this work area, and the idea is that typically if you work with robots in industrial settings, everything has to be very precise because the people or the people in the industry use the robot are for very precise operations. So if you want to hand over something for your robot, you typically put it into a well-defined space, and there is extra machines for separating small parts so that he can operate with separate pieces which are well positioned. But of course, it's much nicer to work like with robots than you work with colleagues. You just give them something and tell them, oh, do something. Yeah. So, but that's of course something that robots are inherently bad at because they have to be programmed to do that. And in order, and of course, big companies with a lot of money, they can do all of this, but small companies or medium-sized companies, they have it very hard integrating this automation tools or this automation technology into the work flow. So if you're asking yourself, and we are always talking about cobot and robot. The robot is a thing which doesn't feel anything. It just does something, whereas the cobot has actually sensors all over the arm. So if it wants to crush into my head or into any part of me, it actually stops. And it also is, like we can see later on, sensitive to touch and to movement. So the idea is that it can easily collaborate with a human, and also it doesn't need any special security. So normal robots, because they can kill you, they need like some security fence or some laser system that prohibits you from coming near it. But here we are actually sitting very relaxed next to it. So on the other side, of the screen, you can see the CP.org webpage, which is the process engine, which we will use for today's demonstration. And I click here on demo. And before 500 people do that, maybe you can work together or something just to not break the server or something, or maybe you can do it afterwards. Everybody can have a go at the robot and steer it over the camera that you can see here later on. But I did everything so that you don't kill anybody here. But before you do it now, let me quick do the demo before something bad happens. So I create a new instance. And when you create a new instance, it's very simple. You just click the create instance. Just put your name if you're going with me. It's just because later on we created the instance number 23 now, but later on the right-hand side, you see this delay 4 seconds in use false and in use by nobody. So as we potentially, many people in this online meeting will now use the robot, I put in this view so that we can see who actually currently uses the robot, and we have this rule engine hooked up to the process engine, which actually protects the robot from being used by multiple sources. So you can always see which person, if you give the process your own name, the process instance, which person actually currently uses the robot, so that we can cheer for him or whatever we do when he does something good or bad with the robot. Okay. So I created this instance number 23, which you can still see up here, and you come into our modeling view. And in contrast to, for example, let's say Signavio, we are not using a like manual layout, but this is an automatic layout editor, which we use because of feedback by our customers, and there is a strong desire so that when 2 people model the same thing, that the result actually looks the same. And also we can like do funny reformatting of the processes in the automatic layout format, so that it's easier for bigger groups of people to work on the same processes. So for the first step, what I'm doing is here, I'm using here this, I can make it a little bit bigger if you want, this load template button. So the general layout is, we have here this new that we were before. We have this instance where you can see operations that you can do on the instance. You can, by the way, import Signavio models if you want, but yeah, maybe you could, but of course there is always, after the modeling, the execution gap where you have to add in like certain things so that it becomes executable. There's this execution tab where you can start the execution. And then we have data elements, endpoints, and attributes. And in the attributes, you can see in the info, you see this, my name. Here you can change your name further so that it shows up over here when we execute. And we have some other information like the model type and the theme and stuff like that. Currently, we don't have many endpoints to use. Currently, we don't have any data elements. So I'm now loading the BPMN 2020 template. And on the surface, nothing changed, but we have now a whole lot of endpoints which are connected to the robot. Yeah? So it's a total of about 11 endpoints, and these can be used to talk to the robot. Another thing that you can see here under attributes is that we have another attribute which is called resource, and here it says UR51 because we have 2 universal robots and they are identified as UR51 and UR52. This resource attribute actually helps the rule engine protect this instance. So, and at some point with our customers, we like did traditional resource locking. So we let them model individual tasks which locked resources, machines, robots, and then afterwards they should be unlocked again. But there were lots of modeling errors regarding this. And also when regular errors occurred, so the process stopped, there was always like a process involved of unlocking resources and of several errors happened. So we switched to this model, which I also employ here in this workshop, which is much simpler. If a single resource has the annotation or a single instance has this annotation, so only one of these instances which has this resource UR51 in it. So don't play with this one, leave it in, or else two people can start the robot simultaneously, which will lead to interesting behavior. The robot itself operates on a proprietary protocol, which we encapsulate by a protocol which is called OPC UA, which is widely hyped and available in the industrial realm. And I, for the purpose of this demonstration, wrapped all these OPC UA calls into these REST service calls, which can be used here in the process. So the first step that we have to do is, as you can see in this picture, we are now looking at a individual little piece that I put on this black paper. I move it away a little bit. So the first step of the modeling is that we want to insert a task where we move in some kind of overview position, where we can see the big picture and actually determine if there is any parts on the workspace. So the manual modeling works like this. You start with a start and an end symbol, a BPMN start and an end symbol, and you insert at this position certain things that you know from BPMN. So it's not possible here to produce any models which are not valid, so they are always syntactically correct. Of course, the semantics is the problem and not the syntax, but here everything that you produce is semantically correct, and there is service call with scripts and service call. The one is just call an endpoint, and the other one is call an endpoint and work on the return value. So for simplicity, we just introduce a service call. Remember, we are in the instance number 23. We have a quick look at the endpoints, and we have our simplified editor with no fancy bells and whistles. We just write the overview in here, and you can see all the ways the parameter sheet here has changed a little bit, and we also give it a label. We call it move to overview. And the editor shows it. As you can see in our editor, we show labels not on the label, but besides it, which is much better for automatic layout, because you put the labels into the tasks, the layout becomes quite difficult. So we are concentrating on these labels on the side of things view. And I do another thing, like I insert a stop symbol or a stop event after the move to overview, because of course I want to play around with it and I want to start this process. So nobody uses it, and so I will start this process, and about 4 seconds later you should see the robot move and the camera move. So we have gone into this overview position now. Yeah. So,
Jürgen, may I?
Yes.
Very shortly, it's just to give you an update that there is approximately 10 minutes left in the tutorial.
Okay, 10 minutes left in the tutorial. Okay, so I'm. Soll ich das gleich sagen? Okay, I'm continue showing you stuff, and I think the beauty about this online scenario is that we have all the time in the world afterwards. So I'll be available throughout the whole evening. So for everybody who wants to play around with the robot and do stuff, I'm just telling you now, but we have still time. So before doing anything, before continuing to commit, I tell you, I'll be here the whole evening, so I'll sit here and you can stay in this Zoom room or maybe even in a private room, and we can continue doing stuff with the robot if you want to, of course. Nobody's forcing you.
That's very nice.
I move to overview, and here you can see that, of course, I have to compensate for the camera delay. So I insert in another task, and this time I use one of the endpoints, which is called wait. And here you can see as soon as I inserted the endpoint, the icon switched. So that's another way that we approach things. We have functionalities, and annotated at the functionalities, there is the meaning of the functionalities. So we see the modeling not from you put the model there and then afterwards you hook up the functionalities, but we actually, the functionalities define what actually a task does. So there is, because all the attributes or all the arguments that you can give it, in this case, we can say we can wait for 5 seconds or something just to be sure and wait. Just to minimize the ways that you can make errors, we are basically supplying every endpoint, also the ones that are not on our service, can be annotated with annotations. And there is, when you look up here, there is this resources, and here the annotation service is running. And whenever you insert an endpoint, is looking it up if there is any annotations available for this endpoint. So I would now go on and model everything, but of course I prepared one process where we can see what actually happens here, and if I close this a little bit so that we can see the full thing. Here you can see how the finished result looks like. So we also have some data elements here, because the red and white panel in the back, this one can be steered at by coordinates. So this is 0, 0, and this is 0, 1, and this is 1, 0, and this is 1, 1. So you can yourself decide on which of these squares that you want to put one of the parts. So there is no millimeter-based steering for the back thing, but only like places that you can put stuff on. So these are the available places. So if you want to put 2 things on the same place, you can of course do this. Let's do interesting things. So we put 2 things on the first space. We move into overview position, as you have seen. We wait a little bit, and then we get the item positions. Yeah. And of course we can explore everything. So let's continue from this overview position. So if I start from here, we should move back down and then move back up into overview position. Then we wait for the camera stream delay, which is 4 seconds, but for sure we wait 5 seconds, and then we get the item positions. As you can see here, this is a task with this script in it, and it's actually rather simple. You have this finalize thing here, and the whole result is available in a variable called result, and we just say data.items is result, and then you can see it up here in the data elements in the items. It showed up as soon as we started the execution. And here you can see that he detected several of these items. So these are basically the predicted positions of these items. In the thing that I'm using here is a clustering approach. So you can see basically the centroid of the cluster and the size of the cluster in pixels, which is very simple. And he should have predicted 3 parts. So we have stopped here in the middle of the process, which in itself is a little bit of runtime adaptation. Yeah, we could of course always move back, but I think we will continue to this point and let the robot run its course through this operation. So what we now do is we take the first of these items and inspect it closely. Yeah. And the first of these items with the 4-second delay is this little cylinder that is there. So now we started a sub process called adjust. Yeah, and sub process is just another endpoint which is called sub process, and it has some parameters where a process which is coincidentally just lying on the server as a URL is started, and then afterwards we do the grip in place. So we took the cylinder and we put it on this first thing, and now you can see the robot is moving down very slowly because we are now making use of its sensors. So he is putting it down very slowly, and as soon as he touches something, he leaves it go and moves back to the initial decision, to the initial position. So an important lecture here is when you do this modeling, so if you want that your process model lives also inside a company, this is not business process modeling like in the sense. Of course, this modeling would probably be done by somebody with some technical knowledge, but nonetheless, it would be a person which wants sometimes to change something. So and at the very lowest level, of course, you have an implementation of all of these tasks that do something. So thinking about the granularity, what task does what, so that I can easily change the process without introducing many errors is, of course, a challenge that is still a valid one. So in this case, in order for you guys, if you want to use the robot, to not like introduce any crashes, I decided that every move operation of the robot is basically always goes back to a safe place, so that you can't drive the robot into the table or into the robot itself. So because the most critical thing is that the robot hits itself, and stuff like this. So I restricted basically the movement. So so for a final thing, I would say we pick up another one of these cylinders, maybe a big one, and put it down. And then I think the tutorial is already coming to a close, and we will break out into a other room. So if we continue doing this, you can see again the robot moving into the overview position. And when you watch here the items, we only have 2 items left on the table. So he takes again the first one, yeah, and inspects it closer. And while the adjust is executed, you should, if you look very closely, you can see the cylinder move into the middle. Because we are trying to position the gripper as precisely as possible so that we can actually grip the thing. In the endpoints, you can see that we have 2 kinds of endpoints, which ones that are called base and ones that are called neural. Yeah, and the base ones are basically based on clustering things, but whereas the neural use a neural network for object detection. So as you can see, we very elegantly placed one of the cylinders on top of the other. You should probably, if you try it out yourself, not put another one on it, or you will probably throw it off the table, which would be
Jürgen, I'm going to interrupt here.
Okay.
I think it is nice that you already mentioned the opportunity for people to stick around, but maybe also for the people, because in 10 minutes we will start with a new element of the program. maybe it's good to do first a sort of a wrap up right now, and then mention that people can stay around for a little bit longer if they want to proceed and discuss how that goes. Is that
okay? So he said we should do a short wrap up and then tell people that that they can stick around. So in order to wrap this up, the challenges of integrating or having a high integration from the ERP level down to the machine level are the same that we already know since many years, but of course there is always the main goal to make it very simple and very approachable what we do for actual customers or for normal people that use it. So that is what we're trying to do here. And if you want to stick around, you can play with this. I will stay here, put on back the cylinders on it. I support you in modeling. We also will let other people stream their desktop so that I can give feedback if they're doing modeling or stuff. We can explore in more detail various solutions. We have neural network solutions. We have examples of solutions with a 3D camera, various approaches that we have done here. And if you like to stick around, you can do so. And else, have a nice evening.
Very good. So I have a sort of a practical recommendation on how to continue doing this.
Yeah.
What you could do is with the WOVA app, and I will put it in a text chat in just a minute, you can create a meetup with the details of how people can join the meetup so that they connect back to you. Because we have to close this session in a couple of minutes, not right away, but through the WOVA app, you can let people join again in a sort of a private session that you follow up on this one.
Okay.
I will give you a bit of the details. I know there are also some questions left, but since we are running into the break, I also leave that for the private, for the more private session. But at this stage, I really want to thank you for a fascinating view into this world of robots, manufacturing, and processes. I found it highly interesting, and I'm very happy that you took the time to do all this. So also on behalf of the organization, thank you for doing this. And to everybody who attended, feel free to stick around for a couple more minutes, and we will release more information for a sort of a follow-up, more private session. Okay, thanks again.
Thank you, guys.
So, are there any questions? Can you still hear me?
Yes, people can clearly hear you. I will stay around for the questions right now, but allow me, or maybe Sergio, if you put in the chat the information to Steffi, how she can set up a sort of a private room.
Sure.
I will guide the questions to you, Jürgen, which may still be here. We had 2 questions, and let me see if I can connect you directly to the people. Konstantinos, are you still in the session? Because you had a question about the execution control module. If you want to, you can raise the question yourself.
Hi, do you hear me?
Faintly?
Yes.
Yes, now we can hear you clearly. Go ahead.
Yes, thanks, Stefan and Jungler. I think my question was more or less answered with the demo. So I was asking how detailed you go in your process engine of modeling the motions of a robot. So I just saw that you do really detail that. But do you think that this approach might get a lot of complex process models? So in a factory where you have many robots and where they do a lot of motions, do you think that can get complex to model all these small details?
I have, in fact, over the last year done many process models for robots which handled many parts, and of course, in this for this particular case, we actually used what we learned. So typically, the people creating the movement models for the robots. They are taking several weeks, even months, to create the robot programs. And the robot programs are always things like do some operations, but they always do it in the same way. So there is no flexibility there. So what we are trying to do normally is hack up these robot programs into individual pieces, which we, for different variants of products, then reuse and start after each other, which is of course dangerous, yeah, because when you start the wrong model while the robot is in the wrong position, he might actually destroy something. And some of these robots are very strong. We have in the pilot factory some robots that can lift up to 200 kilograms, and there is, like, I can tell you, a big safety margin of about 10 meters to this robot.
Wow.
Very dangerous, yeah. He's there for lifting machine turbine parts. Yeah, so for water turbines and other or gas turbines. Yeah, so what we are doing is hacking up these programs, and it really becomes very difficult. And there is a discipline which is called CAD/CAM, which is actually going from 3D models to simulation models to executing these parts. It's very complicated and very expensive, and they try to simulate or create digital twins of the whole affair. So the thing is, only very big companies have the kind of money to employ the experts that can do this and do this kind of stuff. So what we are trying to do is like introducing some very simple safety mechanisms and make the whole thing more approachable. And actually what you can see here is we can later on watch into the configuration of the whole setup. So what the companies want is, with a very simple and understandable step-by-step approach, creating such a solution. So what we are doing is we are giving them some kind of plan that they have to produce some certain static programs, like drive to the homing point, drive to an overview point, do a relative movement inside some bounds, and the rest is done through the process modeling. And what is also an important step for safety is that the robot can never start a program when he's not at a certain point. So we are looking always at the end position of a certain robot, and he can only continue to work when the next program that is started is also within a certain range or with certain rules connected to this end position of the program, to split up the robot programs and to make this robot programming much simpler and bring it down to a level where it can be easily modified and used as a tool, and not like a magic thing that I create once and then never touch again, because everything is very like unapproachable.
Okay, very good.
Thank you.
There was one. Answer your question, Konstantinos? Yeah.
Yes, thanks.
Okay. There was one more question, but the person asking the question has already left the session. So I will leave it up to him to perhaps contact you again if he wants to hear more about it. Are there perhaps any other questions from the audience still?
I think Stephanie had another remark.
Okay, go ahead.
Follow up for the last question.
I just wanted to add that the complexity, so we make use of this.
We cannot hear you very well, Steffi.
Okay. So for the complexity question, we make use of these sub-processes, super processes, and to tame, let's say, the complexity of the process models.
Okay, so what I suggest now, also considering the time, is that we have to close this session at this point, but I hope that Sergio has by now already instructed you how to create this meetup. Yes, Sergio is nodding. So I recommend everybody who is still in the session, who wants to play with the robot, him or herself, or hear more about this topic, to check on Wova for a specific meetup that will follow up on this one. Having said that, I'd like to thank everybody again, both the organizers and the participants, for joining. It was a great tutorial. Thank you very much.
Thank you. Thank you very much.